Okay, good afternoon, class. I don't see anybody in the chat room right now, but I'm going to go ahead and get started because we have quite a bit of material to cover. So we're going to finish up Cycle 1A, and we're going to go over Section 4.5, and then the statistical literacy material, which is only available in my courses, the handouts and so forth, but the homework is in my math lab. So let's take a look at 4.5. So we remember back in section 1.8 we learned about the means, the measures of central tendency, or the center of a data set. So we learned the mean, the median, and the mode. This time we're going to talk about measures of variation, and we're going to look at something called the range. And so now we're interested not in just a typical value or an average for a data set, but how much difference is there among the various data points in the data set. So the range is the difference between the largest and the smallest of the values in the data set. Most students have heard of the range, the maximum minus the minimum. Now the problem with this is it only uses two data points, the max and the min. The rest of the data we collected is not used at all to calculate the range. So let's talk about a measure that uses all the data, and it's called the standard deviation. And it's actually an average of the deviations of each data value from the mean of the data set. And we're going to work through an example in a minute, but it's called the square root of the average squared deviations from the mean. And the units of the standard deviation are the same as the units of the original data, which is nice. So if two data sets have the same units, then the data set with the larger standard deviation is more spread out from the mean, and the data set with the smaller standard deviation is less spread out. The smaller the standard deviation, the more consistent or the more tightly clustered the data values are. So let's take an example. So pastry chefs use accurate scales to measure quantity by weight. And in fact, the United States is one of the few countries where we measure volume instead of weights when we cook. Volume measurements like cups and tablespoons are not as exact and can vary according to humidity, how tightly or loosely the cup is packed, and so forth. So let's take a look. We're going to work an example with this pastry, and here on your book on page 486 it talks about how to calculate the standard deviation, and it gives you a suggestion of making a little table like this where you have the column with the x values, the data values. You need to calculate the mean, and then in the second column you take each data value, and in this case the mean for this one was 14. We subtract the mean from each data value, and then the last column we square whatever we found in the second column, and then we're going to get this average of the squared deviations down here. The second column in this little table always adds to 0, so that's a nice check to make sure you didn't make a mistake. Okay, so let's look at the pastry chef again. She measured the flour, 1½ cups 3 times, and she got these weights, 175, 192, and 179. Find the standard deviation of the weights. So we're going to need the mean. So to calculate the mean, we add them all up and divide by 3. And we're going to create a table like we have in the book. So just like in the book, I've got each data value. Here I've taken each data value and subtracted the mean of 182. And then I squared those deviations. Notice here they add to 0. And then I added up the squared deviations. So the standard deviation is going to be the sum of the squared deviations divided by the number of observations, and then we take the square root. And for this example, we come out with a standard deviation of about 7.26. If the chef measures the flour using a scale and gets exactly 185 of flour each time, what is the standard deviation of the weights and why? All right, so in this example, there's no variation, so the standard deviation is going to be 0. Another example from your book on page 487. A biology department has a course with 4 sections per semester of anatomy and physiology. The class sizes are 60, 63, 68, and 81. Find the standard deviation for the class sizes. Okay, so what you're going to do here, just like we did before, is you're going to find the mean first, all right, and in this case the mean was, I didn't write it down, so the mean must be 68. And then in this column we take each data value, subtract the mean, and then we square the deviations, we add them up, and then the standard deviation is going to be the square root of the sum of the squared deviations, 258 divided by 4. Do that division first, and then take the square root, so it's a little bit more than 8.03 students. Without performing any calculations, match each data set with its standard deviation. Okay, so we have 4 data sets here, and we want to see which standard deviation most likely matches up to that data set. So let's start here. Let's start with a 0. So we notice right away that data set C has all the same data values, so that must be the standard deviation of 0. And then which data set has the most variation? If we look at the values, we notice that set D has the largest range. So therefore, we would expect that set D would also have the largest standard deviation. So we're left with the first two. And so the one with the smaller range is going to have the smaller standard deviation, and that's going to be this data set here, which is going to match up with 10.26. And then finally, the top data set would have the standard deviation of 14.51. And so there's our answers. And I'm going to be right back. I've got to go check on something, and I will be right back into the class. All right, we're going to move on now to the statistical literacy material. And this material, there are handouts, there are videos, there are activities, all in the Cycle 1A module in my courses. In my math lab, you have a homework assignment, but you don't have the resources available because this particular lesson is not actually in the textbook. We added it to the course. So lots of definitions in this section. Random phenomenon are where we know the outcomes that can occur, but we don't know which particular outcome will happen each time we perform a trial, which is each time we observe a random phenomenon. So for instance, if we flip a coin, we know we can get a head or a tail, but we don't know what's going to happen until we actually conduct the trial. And then what happens at each trial is called the outcome. So if we were flipping a coin 100 times, each time we flip it, we would write down the outcome. The collection of all the possible outcomes is called the sample space, and we designate that with a capital letter S. So for the flipping the coin example, the sample space is simply heads and tails. We can group the outcomes into events. So if we were rolling a die, we could talk about one event being we get an odd number or we get an even number. The fundamental counting principle is a way to help us determine the total number of outcomes in a sample space. So if an experiment has N1, the first one has N1 distinct outcomes and the second has N2, then the possible outcomes for experiment 1 followed by experiment 2 are N1 times N2. So for instance, my flipping a coin and rolling a die, when I flip a coin, I have 2 outcomes. When I roll a die, I have 6. So if I flip a coin and then roll a die, I have 12 outcomes in my sample space. Here's another example. If the first experiment has 3 outcomes and the second has 4, then conducting experiment 1 followed by experiment 2 would have 3 times 4 or 12 outcomes in the sample space. Tree diagrams are a helpful way to calculate or determine sample spaces, and they're actually pictures. We've done a lot of pictures in this course, and this is the flipping a coin, rolling a die example. It's called a tree diagram. So when I flip the coin, I get a head or I get a tail. Then I'm going to roll the die. So I can get 1 through 6 if I had a head first. I could also get 1 through 6 if I had a tail first. So here are the actual outcomes, 12 outcomes in the sample space. Okay, let's try a couple of problems with fundamental counting principle. Your garage door opener requires a 3-digit number code using the numbers 0 through 9 to open the door. Determine the number of codes that can be used if we can't repeat the numbers. So in the first digit, we have 10 outcomes. Whatever we pick for the first digit, we can't use again. So for the second digit, we have 9, and for the third digit, we have 8. So we have a total of 720 codes. Notice the difference if we could repeat. Then we would have 10 times 10 times 10, or 1,000 codes. A shoe store carries 1 brand of shoe in 4 styles, 3 sizes, and 8 colors. How many types of shoes are available for this one brand? Fundamental counting principle, so we're going to take the number of styles, 4, times the number of sizes, 3, times the number of colors, 8, and we get 96 styles of shoes. So more definitions. Statistics is a way of reasoning along with a collection of tools and methods designed to help us understand the world. Statistics are also the calculations that we make from the data, for example, the mean, the range, the standard deviation. The population is the big group we're interested in knowing about. A census collects information about every member of the population, while a sample is a subset of the population. The samples need to be representative of the population so that we can make valid conclusions about the population. Every time we draw a sample from a population, it will contain different cases or individuals, and the statistics that we calculate will vary from sample to sample. And we know this, statisticians know this, it's called sampling variation or sampling error. A parameter is a numerical characteristic of a population. Parameters are generally symbolized by Greek letters, and I apologize that my Greek letter here has shifted over. This is supposed to be a mu, Greek letter mu for mean, which looks like this. If I can draw it with my mouse, mu. And for standard deviation, we use the Greek letter sigma. And when we do statistics, we use English letters. X bar we use for the mean, and we use the lowercase f's for standard deviation. Population of interest is the larger population from which we took the sample. So an easy way to remember this, population parameter, so when we're talking about the population, we're talking about a parameter. However, we draw a sample and calculate a statistic in order to make an inference about the population parameter. So sample, statistic, population parameter. Variables are the data that we collect from the cases, the information that we collect from the cases. And we have different kinds of variables. We have quantitative that are numerical, and these have units, things like height, weight, age, etc. And then we have categorical, which are generally name variables, things like gender, political affiliation, religious preference. Things like that are categorical. They put the cases into groups. They're not numerical. And then finally, identifier variables are simply what we use to identify the case from which we drew the information. Things like student ID, social security number. We don't do any statistics or graphical displays on identifiers. They're simply there to help us identify the individual cases. So how do we collect data? We could do a census, which we mentioned before. We can take a survey. We can do a survey. We can do a study. We can do different kinds of studies. Observational study is where we follow large groups of individuals, generally over time, and it can be prospective. We identify the people now and we track them forward. Or retrospective. Retrospective, key phrase you'll see is reviewed records, reviewed medical records, reviewed college records. So we identify the cases and then we look back into their data or history to determine information, to collect variables. An experiment requires random assignment of the subjects or the items to two or more groups. So how do we sample? Sampling methods. Simple random sample. Every sample is equally likely to be drawn. Stratified. The population is divided into homogeneous groups called strata, and then we take a random sample from each stratum. So for instance, we could talk about males and females. So we could take a random sample of males, a random sample of females. That would be called stratified random sampling. Cluster sampling is where the population is divided into representative clusters that are heterogeneous and representative of the whole population. One or more clusters is randomly selected, and then every member of the cluster is sampled. Notice the difference here. We randomly select the clusters, then take information from every member. In stratified, population was already in the groups, and then we took a random sample from each of the groups. And sometimes cluster is called geographic sampling. Systematic, we pick a random starting point and then we take every nth case or individual to get the desired sample size. Convenience is where we pick people or things that are easy to get, and these are generally not representative of the population. Okay, let's work a couple examples. A soft drink manufacturer wants to make sure the bottle caps on soda are sealed and do not come off easily. They sample every 20th bottle off the production line and find the seals on 3% of 50 bottles tested failed the seal test. What is the population of interest? The big group from which we took the 50 was what? The bottles that are manufactured at this particular manufacturer. What was the sampling method? Key here is 200th. This is systematic. The 50 bottles is known as what? So we took the 50 bottles off the production line, and that is the sample. And is the figure 3% a parameter or a statistic? It's a statistic because we calculate it from the 50 bottles. Let's try another example. Some people who race greyhounds give the dogs large doses of vitamin C in the belief that the dogs will run faster. Investigators at the University of Florida tried 3 different diets in random order on each of 5 racing greyhounds. They were surprised to find when the dogs ate high amounts of vitamin C, they actually ran more slowly. Is this an experiment or an observational study? It's an experiment. Notice the order. They gave the diets in random order. What's the parameter of interest? They wanted to see how the vitamin C would affect the running ability. So the thing we're going to measure is the running ability of the greyhounds. What were the treatments? They didn't tell us exactly, but they said 3 different diets, so they probably have different levels of vitamin C. Could these results be applied to all breeds of dog? No, because we only tested greyhounds, we can only make the inference back to the greyhounds. Maybe beagles do run faster if they take a lot of vitamin C. We don't know. We only tested greyhounds. In a test of roughly 200 men and women, those with moderately high blood pressure did worse on tests of memory and reaction time than those with normal blood pressure. Is this an experiment or an observational study? Okay, this is observational because we're not doing anything. We didn't assign these people to have high blood pressure or not have high blood pressure. We're just observing them. What's the parameter of interest? What we're interested in is whether or not the blood pressure affects what? The tests of memory and reaction time. What does the 200 men and women represent? That represents the sample. How were they selected? Many times information is not given, and in this example they didn't tell us how they selected the men and the women. In 2000, Consumer Reports published an article evaluating refrigerators. It listed 41 models, giving the brand, cost, size, etc. A lot of variables. For each variable, identify the type, and if it's quantitative, what are the units? So let's start with model. Notice it said 41 models, so we can probably assume that that's an identifier variable. For brand, there are probably more than one particular model per brand, so this is going to be a categorical variable. Cost, okay, cost is going to be quantitative and the units are dollars. The size was given in cubic feet, so it's also quantitative. The type, top freezer, bottom freezer, etc., that would be categorical. Annual energy cost is quantitative and the units are dollars. Overall rating, poor, good, etc., so that's also categorical. And then let's just finish up with some sampling technique questions. Every 20th can coming off an assembly line is checked for defects. What kind of sampling is this? Systematic. A $50 gift certificate is given away at the annual bankers convention. The tickets are placed in a bin and mixed up, and then one ticket is drawn. This is a simple random sample. Every ticket is equally likely to be selected. Children in a large city are classified based on the neighborhood school they attend. A random sample of 5 schools is selected. All the children from each selected school are included. Key on here is random selection of the schools, and then all the children in the schools are included. This is a cluster sample, also geographic. The first 50 people entering a zoo are asked if they support an increase in taxes to support a zoo expansion. Convenience. And then last example, viewers of USA Network were classified according to age, and we take a random sample from each age group. Homogeneous groups, this is stratified sampling. Okay, so this finishes up Cycle 1A. Next week's chat, we will go over a copy of the midterm prep quiz to help you get ready to take the midterm. And I will post that copy before the chat so that you can look through it before we get together. So we're almost halfway through the course, so hang in there. We're getting back on track after the hurricane, and the class is doing very well. So have a great week, and we'll chat again next Monday and go over a copy of the midterm prep quiz. Literacy